What's up everybody? Today I'm going to show you how you can replace the broken voltage regulator in your Arduino. Now in front of me I have three Arduinos. The one on the left is the one that is broken. The one in the middle is one that I have already tried to replace and have replaced, but I ran into a little bit of trouble with the hot air gun. As you can see, I kind of melted the connector there. And then the one on the right is a genuine Arduino that I will use for comparison purposes. And if you want to do this, then the chip that you need is the AMS1117. It's a 5-volt voltage regulator at 1 amp. You can get these off of AliExpress or Amazon. But if you don't want to order them online and you don't have to wait, then you can just harvest them off an old Arduino like the one I'm showing on camera here. It also has that chip, so you can just desolder it and use it for the Arduino that you need. You can tell that one's just a little bit dirty just because it's been sitting for so long in my parts drawer. But yeah, that's how you can get that chip if you don't want to wait in order to get it. And the reason that these Arduinos have the broken voltage regulator is because I tried to use it with my ramps board for my 3D printer, and that ramps board can actually supply power to the Arduino, but as you can see from the voltage regulators, it's a little bit too much. And I looked up the issue online, and a lot of people pointed to the voltage regulator just not being up to spec, because I double checked my wiring and everything was correct. And so I tried it 2 more times and the voltage regulator just couldn't handle it. Some said that the voltage regulator on the genuine Arduino could handle it, but I wasn't willing to take that chance. So instead I just cut the power from the ramps board and powered the Arduino separately, and that's how I got around that. Now the one I tried to replace, you can see on camera there, I tried using hot air to replace it, and I melted the connector before I melted the solder. And then I resorted to, trying to use force to pry off the voltage regulator while putting the soldering iron on the pins, and that ended up ripping the pad a little bit on the top there, but fortunately there was enough pad left over to where I could get a good join. And I tested it and it works, so it's all good. And then the one on the right there, that's the genuine Arduino. Now that voltage regulator there, I tried to Google those part numbers. I couldn't find anything available for it. I tried to find them. I tried to buy that regulator because that's the one I wanted to use, a genuine one, but it wasn't readily available. So we just went with the AMS1117. And now I'll show you how I burnt these Arduinos using the ramps board. Alright, so here I'm back in my 3D printer. As you can see, I wanted to drive it using the ramps board, and the ramps board was actually what caused the Arduino to overdrive that little voltage regulator and eventually burn it. There was a diode here that I needed to cut, which I did cut. I know you can't really see it right now, but once I cut that, then the Arduino was no longer being supplied by the ramps board power, and I actually needed to power it off of USB. So if you could just, yeah, there you go. So I actually need to power it off of USB on top of powering that ramps board through those connectors right there. So that was the solution to that, and I have paper towel here where all the electronics sit on top of, because this enclosure here is all it's conductive, so if I were to put it on there, it wouldn't turn on. Okay, so before we actually get into replacing the voltage regulator, it's a good idea to check if it's still working, because if it's still working, then you might not even need to replace it. However, in this case, I am going to replace it because the damage is clearly visible. So what I'm going to do here is I'm going to take my multimeter and I'm going to measure the voltage coming out. And there you can see that once I plugged in the battery, the LEDs came on. So it is working, but I'm going to measure the voltage just coming out with my multimeter. And so here I'm bringing in my multimeter, and I'm just going to take those leads and measure the voltage just coming out of that regulator. And so there I get a reading, but as you can see, the ring light kind of gets in the way. So I just readjust the multimeter so you can see the actual reading that comes out of that voltage regulator. And so you can see that reading comes out to 4.88, which is okay. But now I'm going to take the genuine Arduino and we're going to compare it to the voltage regulator on that. And so I'm bringing my multimeter back, setting it so you can see it clearly, and then taking the reading, and you see 4.99, which is almost 5 volts, which is, it's really good. And now I'm going to take the one I already replaced just so you can see the reading on that. So this should be closer to the reading we should expect once we replace that voltage regulator on that broken Arduino. And it looks like it's going to be 4.95, so kind of close to 5 volts, but not really. You can see that Arduino there was loaded with the blink example to ensure that it was working properly. And so here I'm just peeling the tape back on the reel that, the voltage regulators came in. Just plopping it down. And so just a fair warning, if you're going to use hot air, just be really careful, because as you can see on the on that Arduino that I already replaced the voltage regulator, I ended up melting the 9-volt barrel connector before I even melted the solder, and that's when I stopped and I tried to go about it a different way. So here I'm just zooming in, trying to get you a better view, because I'm actually going to take that soldering iron and then start to remove that voltage regulator. And so the way I'm gonna approach this, because the hot air didn't work, is I'm actually gonna try and trim those 3 little legs right there, and then I'm gonna apply some solder to the top, and then heat that up, and with the tweezers I should be able to pull on it. Just because, if there's 4 points of contact, you can't apply solder to all 4 points, or apply heat to all 4 points and then pull it with the tweezers. So I'm gonna try and snip those 4 legs with something. Maybe you'll see later on that I try to cut them, but it doesn't work out that way. And so I take a nail clipper to them and try to cut them that way. And then I apply solder to the very top of the 5-volt regulator, and then with that I just pull it straight out. And so here I'm just trying to adjust, the camera to get a better view. And that right there looks just about right. Alright, so the first method that I tried in order to get cut those 3 pins on the regulator is I actually pulled out an X-Acto knife, and I tried to apply pressure in hopes that that'll cut right through the metal. But as you can see, I did that, and it didn't work out. you can see that I was kind of able to make a small little dent in one of them, but at this point it was getting a little sketchy. I was kind of afraid that, you know, the knife would break and then something would fly into my eye. So I just applied a little bit more pressure, and then when I saw it wasn't working, I switched to something else. And so here, I just decided instead to take some nail clippers to it, and, you know, hopefully it would reach the pins in order to get an accurate, you know, crimp. Instead of clipping nails, we're clipping pins, but we're gonna see how that went. And so here I'm trying to get the nail clippers to, you know, get some good grip on that pin so that I can clip it clean off. And there you can see I got it, and it clipped it, and there you see it's kind of crimped. I wasn't really sure if it was actually clipped all the way, so I just went at it a second time and kind of wiggled the nail clippers to make sure that it was fully detached from that regulator. I was taking the magnifying glass and kind of looking in order to see if it was actually, you know, detached, and it looks like it was, but, you know, I actually took that X-Acto knife later on, and I went through that little that separation point, and it worked. And here you can see what not to do. I took the nail clipper and I pulled straight up, and as you can see right there, that looks like a little bit of exposed pad. So you can see me kind of freaking out looking at the regulator. In the end, it turned out that it wasn't exposed pad. It just ripped the solder, but it definitely did look like a little bit of pad. So then now here I'm clipping the last pin, and I got a good clip. I'm wiggling around a little bit, but not as much as I did with the second one. And so now that all three of those are clipped, we can now move on to adding solder into the top of the regulator and then getting that off. Okay, so after I heated up the soldering iron, I tried to take some solder and I tried to heat up that pad, and I tried to just, you know, hope that it would flow, but it had a little bit of trouble flowing in. So I had to add some flux later on, and you'll see that in a little bit. And so you see it still doesn't want to stick. And so after this is when I start to add the flux. And the flux I was using is not the proper flux you should be using. I was using a flux that you use for plumbing, but I didn't have any electrical flux laying around, and I thought it would work just fine. And so we take the soldering iron to it one more time, get a nice bead of solder on there, and you can see it flows right in. And so now we take the tweezers, heat up that solder joint, and lift straight up, and you can see we have now removed the voltage regulator. The next step is to remove the pins that we clipped off earlier. So right now you're going to see me prep the soldering wick that we will use to clean up the excess solder. But what I'm going to do next is I'm actually going to take those pins out, and then we're going to clean up the joints. You can see they come off really easily with just a little bit of heat. So they're definitely much easier to remove than that top piece of metal on that regulator. And so there I just take the soldering wick and I rub it on that pad just to make sure it gets all the solder out. And then I take it to the little pads for the pins and clean those up. And I was really happy to see that that middle pin wasn't a ripped pad. It was just a little bit of solder that came off when I pulled the pin out. And so taking some solder wick to the last one, you can see we cleaned up all the contacts where that regulator will sit. Now it's probably a good idea to clean the flux at this point, but I just went straight in for it. But if you're doing this, it's probably a good idea to clean those contacts and then reapply a little bit of flux, and then try to solder the voltage regulator there. And here I tried to, heat up the pad and the component at the same time, but that didn't work. So I just remove the regulator and I go for the method where I apply some solder to the pad, and then I add the component back, and then we reheat that pad along with the component, and hopefully the solder flows in and it kind of tacks the component so you can solder all the other pins on. So there I'm heating up both the pad, the solder, and the component, and you can see the solder kind of flows right in. So now that is tacked, and then you can move on to soldering the other 3 pins. And there I'm just applying a little bit of solder to the pin. It flows right in, but as you can see, it's a little too much. And that's not really a big deal. You can just take some solder braid and then put it over that pin and it'll suck the excess solder. But that's really not that bad. You can just leave it like that if you want. I do kind of add more solder to the rest of the 3 pins and then just take the wire braid to it, as you'll see in a little bit. So as you can see, I kind of added way too much solder to all 3 pins. But as I said before, you can just take that solder braid and then put it over the 3 pins, take the soldering iron, and the solder braid will suck up any excess solder. And so you can see the joints don't really look that pretty. I could have probably added the soldering iron to them just to have them reflow and look a little prettier. But that looked good enough to me, and it was kind of hard to work under the camera. So after this, I just took a cotton swab and some isopropyl alcohol, and I cleaned it up, and then we went straight to the measurements. And so here I'm gonna zoom back in just to do one final inspection and make sure that all the pins are actually making contact with the pads. You can see I will take my magnifying glass and inspect all the pins. Obviously the solder connections aren't the prettiest, but you can see they are all kind of making contact. You can even make out the part numbers on the regulator. And so now I'm just zooming back out, and then I'm going to focus in, and I'm going to take the final measurement to see what kind of result we get. Plugging in the battery. So now I just darken and we can see that the Arduino comes to life. So that's a good sign. Obviously we still need to measure the voltage to make sure it's not overvolting the Arduino or undervolting it. So they're just positioning it for you to see. And then I'm going to take the leads and take a reading. And so there you can see that we get 4.98, which is, it's pretty good. I mean, it's pretty close to 4.99, which if you remember, that was the reading that we got on the genuine Arduino. So if you enjoyed the video, please make sure to hit the like button, and I'll see you next time.